So this is an extension on the redox video, looking at how we can balance some slightly more complex redox equations. Okay? And the reason we might need to balance a more complex one is because not all redox reactions involve ions that have only got one element in them. Sometimes they've got those polyatomic ions in them, or things which are covalently bonded. Okay? In those, generally we've only got one element which is either oxidized or reduced, but we need to balance all of them to get a balanced equation. And most commonly, the ones we're messing around with, the extra ones, are hydrogen and oxygen. So let's look at some of those examples. The steps, first of all, and I'll go through the steps and then we'll look at an example. The first thing we do, as always, is we divide it into the oxidation and the reduction half ones. And you balance those as best you can to start with. You balance first the elements that are other than hydrogen and oxygen. Then, to balance oxygen, we add water, remembering that this is an equation that's happening in water, so there's plenty of that around. Then we balance the hydrogen by adding H+, because anytime you've got water, you've also got H+ in that solution, so there's plenty of that around as well. Then we balance the charge by adding our electrons, and then we combine them to make sure we gain and lose the same number of electrons. So let's look at an example. We've got permanganate, we're reducing it to form manganese ions. So this information here would be given in the question. Very first thing, we look at our Mn, our manganese, and we say, is that element balanced? We've got one on the left, one on the right, we're okay. Then we need to balance the oxygen. We balance the oxygen by adding water. So we had 4 oxygens on the left, so we need 4 molecules of water to balance that out. Now by doing that, we've upset it because we've added more hydrogen, so we're going to need to balance out those hydrogens. In each water there's 2 hydrogens, so when I add 4 waters I add 4 hydrogens, so I add 4 H+ on the left hand side to balance that. Now I need to balance the charge. So if I go back to this stage, currently 1 minus 8 pluses gives me a charge of 7+ on the left. 2+ on the right, because this is not charged, but that one is. So we need those charges to be equal, and we're only going to be able to equalise them by adding electrons. Okay? So we've got 7+ on the left, 2+ on the right. We add electrons to get to the most positive side to get them equal. So we add 5 electrons to the left, so that the charge is 2+ on both sides. Charge doesn't have to be 0 on both sides, it just has to be the same on both sides. And then finally, we're going to add some states. Okay? In this case, everything's aqueous except for water. Water is a liquid. And electrons do not have a state.